Hello and welcome to the session on elastoplastic material definition for OptiStruct NonLinear. In this session, we will see how to define an elastoplastic material in HyperMesh for OptiStruct. Let us do this with the help of a demo. Let us open HyperMesh. First, let us set the user profile to OptiStruct. Click on OK. Next, let us import the model. Click on Import. Let us close this. We are going to consider a cantilever beam. The one end of the beam is subjected to a load and the other end is constrained. In this model, we have already defined the parameters related to nonlinear analysis. The only thing that needs to be defined is the material. First, let us create a load collector for table S1 for inputting the stress strain curve. Right click on the model browser, create load collector. Let us give the name as stress strain. In the entity editor, set the card image to table S1. In the table S1 number, set the desired value based on the stress strain curve. Let us now enter it as 3. Click on this icon. This will open a table where you can enter the stress strain curve. Here, the values in X represents the strain and the values in Y represent the stress. Next, let us enter the stress strain curve. Once the values are entered, click on Close. This defines the stress strain curve. The next step is to define the material. To define the material, right-click on the model browser, create material. Let us give the name as steel. In the entity editor, set the card image to mat1, which represent isotropic material. Next, let us enter the value of E, nu and rho. The default value, which is here, are for steel. For defining the elastoplastic material, search for mat S1. Check the box next to mat S1. We will get more options. For TID, we have to specify the stress strain curve created. Click on OK. For type, select plastic, which represent the elastoplastic material. Next, select 1 for yield function, which represent von Mises stress. Next, we have to define the initial yield point using limit 1. Let us enter the value as 250. The value here and the first value in the stress strain curve should match. For type strain, enter it as 1, which says that the values of X represented in the stress strain curve are plastic strains. For total strain, we have to specify the type strain as 0 and we have to make sure that in stress strain curve, the values of X represent the total strain. Let us see one more way of defining the elastoplastic material. For that, let us create one more material. Let us give the name as steel. In the entity editor, set the card image to mat1. Enter the value of E, nu and rho. Search for mat S1. We have to set the type to plastic for elastoplastic material. Next, we have to enter the value of H, which is the plastic modulus. It is the slope of stress versus the plastic strain. For elastic perfectly plastic material, we can enter the value as 0. Next, set the yield function to 1 for one misses. Specify the initial yield point with the help of limit 1. Let us enter it as 250. These are the two different ways in which we can define an elastoplastic material. Thank you.